Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift, and this time we're continuing on this work with Monadic, I guess, parser combinators. A parser combinator is something that takes an existing parser and makes a new parser out of it. So we've been working on the sequence combinator that takes two parsers and makes sure you get the first thing followed by the second thing. Otherwise, it fails if either or both fail. Let's take a look where we are. I haven't, all I've done is bring it up and run it. I haven't looked at this all weekend or anything, so it's going to take me a minute. All right, let's see where we left off. Let's go to our to-do. That's always a good idea. And today's the 26th. Okay, so one thing we're looking at is removing sequence calls. So we defined this new ampersand overload operator, overloaded ampersand, I guess you'd say, that takes care of the sequence things, but we weren't using it everywhere. And I don't know if there's an issue with it or what was up. We took a stab at an optional argument, basically a postfix version. We have one that's prefix. It's a function call. You call it. It says optional. And then we still have kind of an open issue around A versus array of A. And I don't know, there's an argument for making all these parsers return arrays and then just letting them fold with this bind operation we've been defining. But the bind is the monad bind. Let's see if I can dig that up here. It's not going to be on that one. It's going to be on the regular parser. Okay, so monad. Right, we're using it here. All right, so it takes two types. It takes a parser, or in general a monad, but that's deeper than I can go. It takes a parser, and it takes a function that takes a value returned by the parser and makes a new parser out of it, and then applies that function. So it fetches the value by applying the first parser, and then the function gets the value resulting, and it parses the rest of the thing. So it's a little complicated and a little unintuitive why you want this, but I think what we can say is this thing, it gives us a chance to deal with the result of the first parser. This function can do anything with that value it wants to, and that's kind of the key to what's going on. So, and I think, this is where I'm starting to kind of get this notion of the monad letting things happen or controlling things. I was trying to imagine like using this for a while loop or something like that, and you gave it, a closure that it can evaluate for the repeat part, and then that function can have, let's say a function you evaluate, then the function could call the repeat here if it wanted to. That's not what we're doing, but it's just kind of nagging on me that that's probably what this thing can do. All right, so we have monad bind, and let's find sequence. Let's find our new sequence. Okay, so here's ampersand A, and it's going to build a parser out of two parsers. So it's a parser returning an array of A's, another parser returning an array of A's, and it results in a parser returning an array of A's. Now this is getting us out of a problem we had, and I'm still not clear if we're doing it the right way. But if you had our sequence parsers before, you get there's two versions. One takes an array of parsers that return A, and then it produces a parser that returns an array. The other takes parsers that return array of A already and produces parsers that return array of A in the end. And the problem we were getting was, as you apply these things, they would stack up. And so you'd start with a parser returning characters, and you'd end up with a parser returning array of characters, and then that thing would be in a sequence returning a array of characters. And if you put that in a sequence, it's array of characters, and you're just getting deeper and deeper. And in the end, like to use it, you're going to have to call, it's going to be like working through an HTML tree or something with CSS, how you can kind of specify the first node, second node, third node. You'd have to do the same sort of thing, like, go to x sub 0 sub 0 sub 0. Now I've got a character and I can work with it. What goes on instead is we call monad bind. We pass in the first parser, giving it a monad bind with the second parser, and then we take the result and compact it. Okay, compact is just a flat map, but because of the typing, I couldn't figure out how to make that go in one thing. The compiler will get confused about the depth of the things it looked like to me. It may be I'm just wrong and I just don't know what I'm doing with flat map, but it seems like we're kind of doing the same thing it should have been doing. Give it a double array and then flatten it. Okay, and by pulling out each entry and putting it in one level fewer things. Okay, so that was our big accomplishment last time, and I don't think my head's totally around it, as you can probably tell, but I think the right thing, it's coming along, and the question I have, I don't know if this my compact should actually be down in the monad bind. The paper I took this from uses it uses Gopher, which is apparently a Haskell variant or something, and I couldn't make enough sense to know, but I feel like it was sort of saying do the binding, the compacting in there, and I don't know. That seems. Let's find monad bind again. So yeah, I just don't know. It seemed to be doing stuff with the array. So, boy, as always, I welcome your input on chat or whatever, or catch me on Twitter, wwake. It's hard to know what's the right way to go with this, but I think we're making progress, because the contrast of if you use this ampersand one, now you have a flattened array of parsers, or a parser returning a flattened array. Got to say it that way. And before we were stacking up the depths, and I think we can be substituting our flattened parser for the real one, and that's what we're trying to do. So let's go to Elm parser. And so I think we did a bunch the other day. So here's one: match and skip, combine it. Okay, match and skip and unwrap and this and that. Okay, the fact that we have to have unwrap still is bugging me, and I'm not sure what's up there. This is, yeah, that's kind of the heart of what's bugging me. Okay, I guess we've already gotten rid of sequence. We got one left. Huh. Now, I almost think we can take this out. A sequence is match of E, little e or big E, and optionally match plus or minus, and match one or more digits. Let's take this out and see if our tests run. Now, I think something was going wrong. I think we ended up with an infinite loop or something. It's hard to tell. And these parser combinators, for whatever their strengths, they're not easy to debug with. I'm definitely finding that. Yeah, this is taking, oh no, it's just slow. No? Okay, that worked. All right. Let's go back to parser. Now, who calls this? Colors, some tests. Okay. And who calls this one? Color is match. Well, let's go back to that second one. This one The only calls are the tests. So I would like to modify these tests to use, well, there's no sense in a sequence of one thing. It's really just a parser of the thing. All right. Well, test sequence one parser returns its result. Yeah, I don't think I want that behavior, or I don't care about it anymore. Sequence for multiple parsers returns array of results. Okay, that I do want. So let's just switch it easily. Let's do digit and digit. And this test should pass. We're looking for 7, 8 coming back. Result, the rest is 9. Okay. Now, let's make sure I'm getting the right tests before I go deleting too much. Okay. Test any with one parser. We're not doing any. All right. So let's modify this. Sequence for one parser returns its result. We really don't care about that. Okay, I'll just comment for a moment. All right, now I think it's more interesting. Match sequence. Let's make it. Let's do it like this. So match character. Let's do digit. I can take these parentheses off in a minute, but digit and digit fails if first parser fails. We give it the input 0.7, doesn't match a digit. That should pass the test. All right, I'm going to move this down because I just want to see success before failure. And then I'm going to do a similar test that says if the second parser fails. Parser rejects the input 7.3. Let's just make it interesting. Make sure it's not skipping over anything. Okay. And let's just run all tests. Okay, we'll get rid of this now. All right, so I think this is a better test. Parser digit and digit. Okay, and we'll commit. So what we've done is we change sequence tests to test ampersand instead. Okay, a good thing. Now this guy. Now this should have no more callers. Yep. Okay, we'll test that. Okay. I don't know why there's two things running, but okay. So we remove unused sequence combinator. Okay, now this thing is used up here. So parsers. Okay, yeah, this So there's two things going on. So there's this match, which you give it a function character to bool, and it tells you if it wants that character or not, if it matches it or not. If it doesn't see it, it returns nil. If it fails the predicate, it returns nil. And once otherwise, it returns a parser that yields a character and the rest of the input. Okay, now the match with string. I don't know. I need more names for these things. So the goal of this is to make a series of matches. I mean, we're trying to make a sequence of, you give me a string ABC, I'm going to parse it by looking for match A on the first character, match B on the second, match C on the third, and that sequence should do that. Now the problem I have is the string. Well, I'm using the word match for both, and one's matching based on a thing, and the other is matching a series, is really a sequence of things. I don't know if I can call this word or token. I'm trying to find a good name for 49's match. It still doesn't address the sequence issue. If you want to match empty string, I guess you just match. I don't know, word. I mean, I think it's like, I think the use of it now, we look for dash dash, say, in our input. Ooh. Nobody's calling this? Oh no, they're calling it in tests. Elm Parser. Okay, I don't know why that didn't show up in the list. Maybe I missed it. Yeah, so we're matching. Well, we're matching one character sometimes. And we're matching multiples another time. Well, I don't mind breaking this out. Match one, match string, match multiple. I mean, I could match a character and I'd be fine. So let's make a match one function. No, I don't know. I mean, really, we've got a list of the string. I mean, really, this is a case. It's like a reduce kind of thing. We're trying to map the characters to a series of parsers. And I don't know if we can. See, I get worried with this because the parsinators, combinators, they're kind of a greedy front match thing. And if you put stuff in that leads it down the wrong path, you can make lots of trouble. But I don't know. Let's see what we got for reduce. Oops. Let's get another window. Put this over here. So reduce. I want to look at Swift reduce. I feel like I've been here before. I don't think there is a reduce one. So that means I have to give it an empty. I have to have a unit of some sort. And my unit for a parser is don't chew up anything, just return it. Now maybe I have an empty. Let's see. Yeah, I see it right there. Okay. Yeah, so empty does produce an empty, it has nothing it accepts. Okay, so let's try it. Can I rename this first? Um let's try match. I'm just going to change it to match string for now, and we can. I hate types and names, so I won't let it stay too long. I hope. Okay, so we have match string, and it's already tested and everything. So we saw lots of tests using it. Let's try. Let's return. We get array of prefix. Okay, so we want to say, well, we'll keep this. That gives us a series of parsers. Um, let's let result equal that. See if the type is array of parsers. Yes, an array of parser characters. So you can see why that other sequence helper was handy for it. Okay, but what I want to do is I want to call reduce. Initial result is empty. And then the reducing thing is ampersand. And we'll return result. Oops. Back up here. Okay. So my type is apparently good. My only worry is reduce. Oh no. Can I qualify it? Yeah. Can I make one that's guaranteed to be characters? Let's do that. I don't know the rules here. Can I specialize both these? Okay. Expected parenthesis. Let's try that. Oh, it's supposed to be. Oh, maybe I can just say empty with parentheses. Empty is a parser. So let's go back to our definition of reduce. Okay, so like this, you reduce with count. We want to use 0 for the base, and then how do you add to it? You got a function that does. Whoops. Okay. Oh, you're still not gonna. Okay, let's try empty character. Let's take this out. He's not really generic on the input side. Ugh. Ambiguous without more context. Boy, I'm tired of that one. Okay, reduce should be a value. Let's get the Swift definition. Surprised this comes up so late. Okay, reduce into initial result. And then you give it a function, result element returns that. And maybe my function just isn't the kind of function I need. Okay, let's try a different tack. I don't know. I go into this mode that it's not really spiking. Well, it's a spiking that I don't know what I'm doing. That part's true. But I'm kind of trying to keep the tests and everything and make it all conform to tests and all that stuff. So it's kind of halfway between a spike and a development, or a spike and a refactoring in this case. So I've got this array, right? This thing gives me a bunch of parsers. Okay, their type is array, a parser of characters. And I want to apply this ampersand operator to them. I don't know, usually I mean, if I require it to be a one or more characters, is that going to work? Well, what I had in mind doing was something like, this is awkward. Well, I was thinking of doing let first equal parsers of 0, which is a parser. And then, well, maybe this is even let result. And then for everything in I sub whatever. Oh, let's see. Do I have a for each? Input dot for each. Well, input dot skip 1. You gotta do that, right? Parsers skip 1 dot for each. Woof. Has no member skip. Okay, arrays must have something like this. Map. Is it drop first? That seems a little harsh. Adding, combining. Prefix. Suffix sub 1, suffix from 1. Containing all but the given number of elements. Drop first. reference to member for each cannot be resolved. Input.forEach is for each. Well, I don't see any difference between these two. If I do suffix from one and drop first, drop first of int. For each, but I'm still messed up on that. No. For each is returning an array slice. Let's look at that thing. I'm looking for anything that lets me iterate over these things. Dot for each with a capital E. I'll get there. Var result. Parser of character. I think I need another layer on here. Ampersand on binary integer. Now, why would that be? It doesn't know the type. Okay, so it wants a binary integer. For each element. I shouldn't even have to do all this stuff. So I'm getting frustrated. Okay. I got a bunch of parsers. Referencing operator function and on binary integer. It almost makes it sound like this is let's do can I do this? Okay. Back up again. Okay, let's make sure I'm still legit. Oh, now my rename did not work. I kind of don't like this match string taking one character. Oh, that's a real match. Okay. Cannot find match string in scope. It renamed them in the test, but not the real code, huh? Okay, well, I don't think that was my issue, unfortunately. Okay. So what I want... See, in the original version of this match on a string, it could say is prefix equal to the result. And maybe that's the way to go. I mean, if we wrote it up like a real... Oh no, but we have characters coming in. Because our parser works on characters. I don't know, you can see it here. When you get first, you get a character. But maybe not. Okay, let's rewrite it as a parser. Let's try return parser with the input in, and this is blanked out. Okay, so we want to say guard input starts with, oh come on, there's got to be a type of input is string, I hope. The problem when you use enough languages is you can never remember what anybody else does. They've all got their own. Starts with colon. Okay. Starts with prefix. Return nil if it doesn't start with it. Otherwise, we return prefix with input.drop first, prefix.count. Okay. Input has no member starts. Oh, we'd have to add it to our thing here. Oh boy. My input has no member starts. Argument passed to call takes no arguments. Well, he can certainly answer starts. we're seeing if this is better or not. Okay. Excuse me. Okay. So he starts with a possible prefix. This is a string. Okay, return input dot starts with. Well, I guess. Okay, is that part good? Ugh. That should be legal to do. Okay, now array of character. Okay, let's run that. Pass or fail. It's time to take a break. So let's take a break. Oh well, we'll see what it does. Okay. Let's take a break. 2 minutes, maybe 3, and we'll come back and continue on. Thanks. Hey, welcome back. All right, so we've switched this match string. We mucked up with the input, my input. So originally my input was just a wrapper around the string. We had this notion that maybe it should be a bunch of characters, but we wanted to at least pull it out into an interface that we can use here. So we just type aliasing it for now. But basically, our parser says you give me an input, I give you the front token and the rest of the input. And if it's bad, I completely throw it away and give you nil. Okay, if I don't find the thing you're looking for, I return nil. Originally, this was string to string. We wrapped it input equals string, then we wrapped it with a new type. We broadened the type, the interface here to be a little closer to string, a tiny bit increment closer, and we added drop first to let you drop multiple characters. Okay, and so I think, well, let's get rid of this, and I think this, I'm going to rename this again. I hope this works a little better. I'm going to call it literal. That's my best word for now. Literal. Okay, now did Elm Parser update literal? Yes. Okay. The only, I still don't know if the literal on a one letter thing is the best. But that's okay. All right. I think literal's been used in enough parsers that I don't feel too bad about it. Match may be the weak word here, but okay. So what we've done is we made match of string, use a different approach, and renamed it to literal. And I don't know, I'm trying to do smaller commits. I could have definitely committed those two things separately. All right. So we've got spaces, new lines, end of line comments. We started on nestable comments, integer literals, floating exponents, and floating literals, the whole thing. Okay, I'm still thinking there's room. Well, the only one I'm really not so happy with right now is the optional. I'd like to say float exponent dot optional. Really, I'd like to make a question mark operator, but it won't let me. But let's take a go at this optional. We started it the other day. Okay, wait. First, this thing I think is no longer being used. Sequence callers, none. All right. Okay, so we are getting simpler. Okay, I got two routines folded down to one with a helper. I don't know, that helper's not really doing much, is it? Seek parser 1, parser 2, they're all declared the same. Let's just pull this in. Yeah, and I did it again. Okay, but we'll carry on with two refactorings in the same commit. Okay, so our commit, we refactored, we kill dead code sequence, inlined seek to amp combinator, remove dead code seek. Okay. And I mean, it's getting there. All right, let's find our optional. Here's optional. Now, the funny thing with this is when you do it as a pure function, you set it up outside like this. When you're doing it as a suffix operator, you do it like this. Okay, and so we're going to try this second one again, and I feel like I was here already once. Okay, but I'm going to provide var opt. I'm just going to take the name a little shorter just to be different. It's a parser producing an array of A's. What is it? Given an array of A's? Given an array. A parser producing an array of stuff, and it's producing another array of stuff. Okay, opt parser. Okay, and he's going to return a parser of array of A with an input in and do something. Okay, so let's see. So basically we're trying to do the same thing as optional there, but we're going to call self.parse instead of its input parser. So this, well, is really this. Parse result is self.parse input. Okay. If the result is nil, let's call it result. If the result is nil, return that. Okay. And otherwise, we're going to return result. Okay. Result dot wrap. Can we do that? Has no member wrap. Okay. Oh, I think it's an outside function still. Okay, so I'm getting lost in my, yeah. I had another word for it. Oh, what did I call that thing? Wrap. Only? Yeah. Now, I don't know if this is the right. Has no member only. Okay. Maybe I return self. So I get balled up. Self or self.only. Okay, trying to get these types lined up. Ugh. Value of optional type must be unwrapped. Oh, yeah. You'd think he would know that from analysis. Okay. We know it's not nil because we just checked it, so it's safe to grab this thing. I'm wrapping the result in an array. Yeah, I don't, let's see. Okay, so new function, nothing's calling it. We're going to swap it in and then swap it into the tests. Okay, and I don't know, this is kind of a pattern I use with my pseudo spikes. I need a better name for them. My probes or something. I don't know. We got to work on that. It's like I'll build this thing. It's sort of like swap algorithm refactoring. Basically, I build up a new version in parallel, plug it in, replace it. Replace it a little bit at a time. But let's find our optionals. Like here's one. I should be able to say float exponent dot opt. Okay. And okay. Somebody's not happy. Maybe this is where I got balled up the other day. Oh, parser character. Yeah, see, I'm messing up. Maybe this is opt. Basically, you give me a parser producing A. Itself is a parser producing A. Then opt is a parser producing an array of A's. Cannot convert value of type array parser of array of character to parser of character. And cannot convert parser of character to parser of array of character. Both these get messed up by it. If I say opt.only, is it gonna? No. Both still messed up. Now I got 3. Okay, so you give me a parser returning A's. You say optional, and maybe this is the monad bind thing again. If you say optional, I should say you get a parser returning an array of A's. Wait, only I'm going the wrong direction on this. Unwrap is the one I want. Okay. But I want to avoid these unwraps. But maybe I'm no. Okay, I don't know. This is kind of where we got balled up the other day, I think. Is there a way to express this with monad bind? Okay, we have a parser returning A, and we're going to give it a function. Let's look at our sequence again. We bind the parser with a result to, a parser and a function. The function says bind another parser to another function, takes the result and flattens it. If I can do something like this. Well, it's like I want the result of this thing to be flattened. Optional should produce a parser of array of stuff. I think the problem is I'm passing in this exponent thing, which is a whole complicated thing. It's already an array of stuff. And this kind of goes back to, should my input be an array of stuff? Would that simplify all this? Then it's just turning array of stuff into more array of more stuff. Found nil while unwrapping an optional value. So this thing attempts to pull off the paren or the brackets and fails. If I'm yeah. I'm messing something up here. Okay, the reason unwrap fails is if you return an empty thing, there's nothing to unwrap. And so we're wishing that my compact got in there somehow. And the problem is the unwrap seems to be required. Why is that? Match mini one. Let me diff this. I think I've been deleting too much stuff. Parend before the literal, parend at the end. Parend before the literal, that's too many. Can you tell me the type of this? No. Okay. He's a parser returning array of characters. Ugh. Okay, I think I'm going to let this one ride again. Literal dot and match character dot many one and optional float exponent or float exponent. Okay. I guess let's diff this. This new opt function. Okay, so let's. Oops. Discard changes. Okay. Let's see. To do. Okay. Remove sequence calls. We did that. Okay, so this is a refactoring. Whoops. Remove sequence calls with that. The optional postfix, I don't think we did it. Okay. Let's pull this guy back to the top. Okay. Let's save that. Run all tests. We should be back to passing tests. So I feel like there's work to do in our grammar still. I think I'm going to have to understand this monad bind more deeply and figure out, I think the compact maybe should be up there. And I have two different papers I'm kind of working from on this, and they seem to have different definitions. So I don't know how to find, well, I don't know how to resolve between them. I guess I'll have to look at some other definitions and take a vote or something. But I feel like things that get rid of brackets, if we can get everything down flat, that seems like progress, because parsers, I mean, well, I don't know. They're not really quite associative, are they? I don't know. Maybe they are with these things that do backtracking. But I'm not sure. So I'd like to get rid of these things, but I think we can make progress on the nestable comments thing again, and that would be good. So let's see. So we have some tests somewhere. Elm parser spaces comments. Okay. All right. So we started in on these tests. I think we kind of had them working at some point, or most of them, not all of them. I think at least these first two worked. And let's run the tests and see. Okay. No, they don't. Let's go back to our grammar. Okay, and our Elm nestable comment. Okay, put on hold. We did. So it's a literal brace dash, and skip any characters that aren't dashes, and then we have an unwrap. And is that unwrap required? Because that seems unfortunate. Okay, but we have literal. Okay, so we skip to dashes. We look for many dashes that don't match dash or brace. And that's a set, really, which is a little confusing. All right. So are we matching this regular expression? So brace dash followed by no dashes. Okay. Then we find a dash. Okay. Well, let's take the empty case first. Let's go to one test. Okay. Brace dash dash brace should be legit. Okay. Brace dash skip to dash does not consume it. And then literal dash brace. This is many, so it should be completely optional regardless of what it is. And I think this test failed just now. And I'm still doing unwraps. And I'm still doing this and that and the other. Ugh. Okay. Is it worth looking at the test? Found a no while unwrapping an optional. So unwrap failed. That's this. Okay, let's comment this stuff out. We just want to find literal dash, brace dash, bunch of non-dashes, dash brace. Does that work? So I'm unwinding my TDD a bit. Should work, but I thought the other one would. Okay. Now let's move on a step. Nestable comment matches non-empty comment. Okay, so there's no multiple dashes. It's just junk. I think this will pass. Okay. Now, a nestable comment ending with many dashes. Okay, this should fail. So we're kind of back in our TDD with a little test teed up here. Actually, I got a bunch teed up. Okay, that fails. Let's go to our parse. All right, so the skip to, I mean, I should be able to say many. Well, I'm at an and, so I should say literal dash dot many and. Okay, so you match the opening. Oh, man. And here's where we're going down this unwrap stuff. And is this all because I don't care what's in these things? I don't know, but this unwrap is a bad sign to me. It means we're not doing this monad thing completely right. So anyway, so we got brace dash, skip the dashes, get one or more dashes, followed by the ending dash and a brace. I believe this will pass. At least it's intended to. Does not. Interesting. What is the failure? Assert not nil failed. Should parse but did not. Okay, so we broke the first one, I wonder if is many a proven thing. Many, many. This is our first use of many. All right, let's check our tests for our parser tests. Many succeeds if parser succeeds multiple times. Okay, so many digits. Well, this seems like a legit test. So we're looking for digits, it finds them. And if you're looking for digits and you don't find any, you still succeed. You just get an empty list back. You don't have anything in your list. That seems okay. Now, I don't know, this is this regular expression-y kind of thing. Literal returns array of characters. Maybe the unwrap should be in here. It returns an array of characters. Yeah, that may be better. We just need... Well, I don't know. No, this unwrap is burning me left and right. Okay, and if we don't have it, it doesn't build, right? Right, so we have a literal... The literal dash returns an array consisting of dash. If we unwrap it, we get the first thing. We get, let's see, the literal returns array of characters. Unwrapping it can't be good because it's already flattened. Many now returns array of characters or nothing. I think if I put only here, I'm going to get a triple, so that's not going to be a good direction. Yeah. Okay, so he's got too many levels, not too few. Okay, and our poor sequence operator is struggling with various arrays of thises and that's. So I think it wants everything to be parser of array of character, which is a parser yielding array of character. Skip 2 yields array of character. Literal yields array of character. Let's check that. Literal is up here. Yields a parser returning array of character. Array of character, and then many I don't know if many is an optional many one. Many one, I'm not sure is the best way to do this either. But many one takes a parser and says you got to get the first result and then repeat. We're going to keep parsing while we can and return whatever result you got. So many says, given a parser producing given a parser producing array of A. Well, this is back to optional flattening or not, isn't it? Ugh. It's like when you're fighting the tools, it's painful. Once we get them all working, the grammar stuff should just be trivial. We should just be able to whip out these new grammar rules left and right. They shouldn't be very hard to write. It does backtracking. Parser combinators are willing to, they're top down, so you can't have left recursion, but they do backtracking, so you don't have to care as much to make sure your grammar's as tightly defined or as constrained. I guess the deal is an optional of a many one, right? That wraps. Okay, where's optional? Up here. If now, I don't know, maybe I need to do this parser in thing and actually flatten things. Yeah, it wraps the stuff. That's just unfortunate. Okay, you give it a parser returning an array of elements. It returns an array of elements. So you give many1. We take some part. Let's take digits.many1 returns an array, a parser returning an array of characters. Okay, and so yeah, it's pulling too many. We're just getting too many levels in because parser's generic. So if this thing produces array of characters and you call many optional on it, it's going to produce A. In this case is going to be an array of characters. It's going to parse an array of characters to produce an array of characters. I don't know. It sounds like it's okay. Let's see what the type is here, if it'll tell us. Optional takes parser of array yielding array and returns a parser yielding an array. Let's try, I don't know, we're going to try a little experiment. Actually, it's a break time. So let's take 2 or 3 minute break. We're going to come back. We're going to run the one test, figure out what it's producing here, and see what's up. I don't know. You definitely get to watch me struggle today. But anyway, we'll be back in 2 minutes. All right, so we only call, let's break it many. We only call many once. So if we just run the one test, hopefully we will just see many once. Yeah. Okay, literal many. I think we put an unwrap and got lost in the unwraps, right? Whoops, I don't want to run all tests, sorry. Oh, well, we're getting on the... I guess we're on the test we want to be. Okay, so optional mini 1. I don't even know where to go. Step into. Okay, so we got many 1 is a parser returning array. Let's step over. Whoa. Let's step in again. Optional. And parser. Well, he's not an ill. Re-abstraction thunk helper. Okay. He's a parser. Here's our many 1 parser. Step over, optional many, out, many succeeds. Okay, I don't want to run that test. We want to run this test. Okay, so we're going to step in and out and in. Okay, print parser. More stuff. Partial apply order with 0.78. Unmangled suffix. That seems odd. Okay. Make sure I'm on the right test, right? Yeah. Okay. Now I'm in optional. We'll step over. Ooh. Out. We're in the unwrap literal. Okay, they're going to blow up on the unwrap. Oh, I don't know. Well, the thing I see happening, it literal. I don't know. Maybe literal of a single character is not the right way to go here, but we're not doing something right on this flattening stuff. But I don't know. I'm kind of back to that. I almost want to make a match 1 that takes a character. Let me try that. I mean, we're definitely red bar here, so I guess it's okay. Let's make function match 1 takes a character, returns a parser returning character. Whoops. Returns parser with input in something. Okay. Well, no, I guess he can just return match with the predicate character equals $0. Okay, so $0. Yeah, $0 is our input. He calls the predicate on the character from the input and checks whether it matches the one we said we would get. Okay, let's swap that in Elm Parser. Match 1. I'm going to take the unwrap off because the unwrap should not be needed. Okay. Match 1, not many. Okay. So what I've effectively done, if you recall our tests for many, they took the digits parser and then they called and verified the results, either one that passed or one that didn't. But either way, they were producing an array of characters, array of digits, and this kind of corresponds to that, I think. Just like the digit pattern, this match literal is doing that. Okay, let's run our. I think our first two tests should pass now. We won't have that unwrap issue. No. Oh. Okay. Oh, it's my breakpoint. Never mind. Does that continue? Test failed. Empty comment. Okay, let's run that clean again. Okay, why are you failing? All right, so let's write this regular expression. We're saying you get bracket dash not dash skip to is star. Okay. And then we're saying dash, oh, because you don't have two. No, many is okay. Whoops. So it's dash, many is star, dash brace. Oh, boy. That seems right to me. Opening brace, skip until you hit a dash. Take as many dashes as you want, followed by a dash literal. So this is a backtracking issue. Maybe my backtracking is not sufficient. I mean, if it was dash plus brace, I would say it's probably okay. Let's take that. And we're going to take that. So we're saying you got to have one or more matches followed by a brace. Okay, so this is match plus. No, none of that. Okay. I mean, I hope it passes the first test. Hope it passes all three. Okay, so I don't understand backtracking as well as I hoped. I had thought it would. Maybe I got to be more careful with my grammar than I thought. So, match 1 is happy to try it as many times as it can. Sorry, many. would try it as many times as it can. I think it found what our test had, 3 or something. Let's see. So in our test here, we had 3 dashes in a row. I think it found all 3 in our many, and then it tried to find the dash brace, but it couldn't find it because it had already committed to 3 dashes, and there's no mechanism that will let it back up from that. Oddly. Maybe, well, no, I don't think there is. Okay, but at any rate, we're... Okay. Yeah, so... Okay, so I think this... Let's get it out of the way at least. Okay. So you skip forward to dashes. Oh boy. So we have to somehow arrange that minus dash shows up. Okay. We match here. Let's break this out a little bit. I mean, I kind of want to make... I mean, something's going on with this. Like, I should be able to repeat this. And we had... I'm not getting the grammar on my feet here, am I? If I don't have that look ahead, it gets a lot harder. So if I found... There's really 3 parts, right? This part, the beginning, there's always dash, brace dash. The end always is a brace, at least. But it's got to have a dash, too. In the middle, I can have non-dash characters. So the skip to stuff is saying nothing's interesting until we hit a dash. Okay. And if you find... Maybe it should be the other way around. Maybe it's the skip to part. I don't know. Maybe these prefix operators might look better. Okay, so we do a skip to, and if we find... I don't know. Do I want to put a matched mini? And we haven't dealt with the nesting at all. um, Golly. So I've skipped and I've got a dash. Okay, one possibility is it's the end of my expression, in which case that thing looks like this. Okay. Or I gotta match one many dashes and something else. Let me take that out. Okay, let's write it in grammar rules first here. Okay, so I gotta have my dash. Okay, I want to do stuff that's not like, how do I do this without lookahead? That's the real thing. I mean, a lookahead is definitely not a dash. We have those characters. And then it's a dash. I'll just quote them. It's a dash followed by well, if it's followed by a brace, we're done. Let's quote those. Okay, if we're followed by brace, we're done. If we're not followed by brace, I don't know, I got a recursive definition here, basically. It's not making me happy. Okay. What I want to let you do is you find a dash, not a brace. Maybe we break this apart. Trying to work out this greedy thing is really twisting my head around. Okay, so the inner stuff is, it certainly can be a bunch of non-dashes, okay, because no trouble comes from those. And then it's a dash followed by not a brace. And maybe this is a dash followed by not a brace. And it's got to be optional because we don't allow, we don't require it. Okay, so if he finds a dash followed by a brace, he says, no, I don't match my inner sequence. I don't match my inner sequence, I don't get to match my star. So it would exit out of here. And then I think this whole thing is this. Ugh. Okay. And maybe I can trim things out a little bit. Like, what if I do this? Okay, so inner stuff. We look for a character that's not a dash, just an X. It's fine. Or we see a dash followed by something that's not a brace. That is sort of an attempt, and this is like a peak. If it is a break, it should fail and go back to the start of this, and then we can pick up the rest. Okay, and if it's a dash followed by, we don't want to. I almost do want a peak kind of thing. I don't know if I can do that easily, but I want to. Well, you can have one or more braces. How's this? Is this better? You get something that's not a brace and it's not a dash. I don't know if I got to say that. Okay. So I'm trying to make this thing become dash inner dash brace. Okay. Let's try it. Let inner comment equal. And somehow it's got to be had except that so don't allow dash or brace. Maybe it's just dash. You have anything that's not a dash, we match it. Or, and again, I can probably put this on one like that. That probably looks all right. Or we have a something dot many. And this thing in here is a dash and not a dash or a brace. Oh. Except one produces. Oh, gosh. Match one produces a single character. Except he should be a many. Match one of character many one. It's a plus. Cannot convert character to parser of character. Except dot only. I mean, the only is really wrap. Okay, my goodness. No, I got things too. This outer many is that this? Thank you. Parser array character to parser array characters. Okay. Match one produces a parser produces a parser returning a character. Match one of many one is an array of parsers producing characters. Except produces a parser of array of characters. Okay. Parse of these two. Well, let's pull it out further. Cannot convert value of parser of character to parser of array of characters. So let's see X's type. Parser of array of characters. Except one dot only. Whether this works, I don't know. Okay. So my inner can produce 0. So that's a good sign for my one thing. Inner comment and literal dash, and this goes away. Now I put an only and I screw it all up, right? The type works. No. Oh. Cannot convert value of parser of character. Parser of array of character. Oh, golly. Yeah, there's just still something wrong. My ampersands can't do the whole job. Somebody's gotta give something. All right, run our tests. Getting too frustrated here. Okay, which one fails? The last one. Okay. Nestable comment ending with many dashes. All right, we got to trace our thing here. Okay, so our inner comment, he should have said match. Well, let's see what our test is. Let's make an intermediate test. No spaces. Now I would have thought both these should pass, so that doesn't help too much. But if one passes and one fails, that'll be interesting. No. The other thing I keep considering is, I worked on compilers years ago, and we certainly put more effort into syntax errors than just saying throw a dill and just call it a day, All right, so this thing is not, it's got three two inner dashes. 1, 2, and the final dash. Okay. It's not going to match this clause. It's only going to match many of these. I'm back to this darned lookahead thing. Okay, so he chews up all the problem is inner comment chews up all those inner dashes, all three of them. Many one says find me all you can, and he does. Finds all three, hits the accept dash brace. He says nope, I do have a brace, so I can't accept this. And now we have no way to uncommit the third one, so it fails the whole thing. And the inner comment says I fail. I didn't find a valid inner comment. And we're left with a nil. Our many says no, it's blown out. It shouldn't have a problem, and it should accept it because it takes 0. So if both clauses failed, it got 0, and it says, okay, I'll give you back an empty brace. And now find a literal dash. Well, it's too late. We've already eaten the last dash. How can we do this? Okay. Well, I'm going to stop here. I think maybe the thing I have to do is figure out this sequence thing. I don't know if this backtracking thing that's a problem. Normally you want that thing to be greedy. You want it to go as far forward as it can. But if it goes too far, it's chewing up other people's things. That's not good. And the problem we have is you can't really backtrack. Like you go forward to the accept and you find out, oh, I couldn't do that. It's just like, the whole thing's bad. I don't know. I got one more thing to try. After you do this, I should be able to say match one dash dot many one. Go back to this. Inner parse character, cannot parse character. Okay, I'm not getting it. Oh no, let's redo that a little bit. Many one, let's try and match one. Okay. I think I'm probably screwing things up. Yeah. No. Oh. Prince. Well, I don't need two onlys. Inner comment is array of characters, right? Literal that. Match one dot many. Cannot convert value of type string. Parser of character dot only wraps that into parser of array of character. Maybe this is this. Sorry. These onlys and unwraps, they're just not reasonable. I don't think this is going to quite do it. Inner comment empty. Maybe it'll fail. Okay. I don't feel great about it, but it's passing. So we will pick up there tomorrow morning, 9 to 11:30 a.m. Eastern time. And I think I'm going to have to dig in and figure out this issue about the monad bind. Should it be doing the folding? And if so, should everybody be using monad bind? And how do we make that go? And maybe our whole thing, maybe we're back to the parsers should be working on arrays of characters. And this should be an array of character, and everything about it should be arrays of characters. I don't know. But we'll pick up there in the morning and see what we can do. Thanks for joining me. Catch you again in the future. Bye-bye.